everybody. All right, so everyone on page 212, we are doing rules of exponents, 4.5. Okay. All right, so I'm going to show you how to do it, but the first thing we need to talk about is exponents. Do you remember how to find and evaluate exponents? Say you had 5 to the third. What do you have to do to find 5 to the third? 5 times 5 times 5. Okay, so when you're multiplying two different exponents, what you have to do is add the exponents together if the base is the same. So the example we're going to do is 4.5a, and it is 5 to the 8th times 5 to the 6th. So what we would do, instead of doing 5 to the 8th and finding the answer, then multiplying it by finding 5 to the 6th and get the answer, we add the exponents.
So it'd be 5 to the 14th.
Yes, 5 to the 14th. Then we would go ahead and do that in the calculator or by hand if you feel like doing a lot of multiplication. But that's how to add exponents. So the next one we would do is b, and that is 7a squared times a to the 6th. What do you think is going to happen to that 7?
It's going to stay there?
Yeah, it's going to stay there, so you bring it over. And now you have a squared times a to the 6th. So what's that going to be?
A to the 8th power.
A to the 8th. And that's it. That's the answer. So the next thing we have is a checkpoint, 30 through 37. And I'd like a few of you to come to the board. So, Gemelix, can you come up and do number 30? Rosalind, 31. Ruby, 32. Uh-huh. Pretty easy? Alright, so when we finish, you're going to go ahead and do 33 through 37. So put that on your separate sheet of paper. Title it 4.5. Okay, so let's start 4.6.
Oh.
Can I erase?
No. Yes. Oh,
No? Okay, I'll give you a minute. Any questions? Okay? Okay. When we do start 4.6, that's going to talk about negative and zero exponents. Do you remember doing that before in your algebra A? When you have a zero exponent, do you remember what anything to the 0 power is?
1.
Correct. Alright, so that's going to be an easy review. Anything to the 0 power is 1. So 15 to the 0 power is?
15.
1.
Oh.
8 to the 0 power?
1.
A to the 0 power?
Oh. 1.
A.
No, 1.
It's 1.
What? Oh.
Anything to the 0 power is 1.
Even.
Anything. 2400 times A times B squared to the 0 power
Is 1.
Is 1.
Oh, okay.
Alright, ready to go?
Yeah.
Okay. Okay, so the example we have for 4.6 is 8 to the 0 power times b to the negative 5. Anyone remember what happens when you have a negative exponent?
Yeah, this is not negative.
What happened?
Yeah,
Answer comes out negative? No. Any other guesses? All right, quick review. So a to the 0 power is
1.
1. anything to a negative exponent moves down to the denominator. See that? B to the negative 5 moved down to the denominator. So what if we had 18 to the negative 4th? How would that look?
18 with to the 4th. Positive.
It would go down to the denominator, 18 to the 4th. What goes on top?
1.
1. Alright? Even though there's nothing to the 0 power there, you would still put a 1 on top. Okay, so the next example we're going to do is number 38. And that is 12 to the negative 4th power. Alright, Celeste, what do we have?
12, 4 to the power 4.
Okay, 12 to the power of 4. And what goes on top?
1.
1. Correct. Okay, I want a few volunteers to come up. Anybody? Anybody?
To do what?
We're going to do 39 through 41.
Oh, I put 39.
39? Okay, 39. 40? Jamlex, 41? All right. There's the eraser. You need it.
What? No.
Anybody have questions? No? This is an Algebra B class, and everything we're doing is Algebra A review at this point. So we're going through the material very quickly.
I'm doing 41.
Yes. Alright, so 39. 6 to the 0 equals 1. That's correct. 40. 7c to the negative 3rd power is actually 7 over c to the 3rd. Okay, because it's not 7 to the negative 3rd. It's 7 to the 1. Whenever you don't see an exponent, it's to the 1st power. So 16 by itself is the same as 16 to the 1st power. Alright, so 7 by itself stays on top. C to the negative 3rd power would bring the c down to the denominator and change the negative 3 to a positive 3. Over here, 15 stays on top, that's correct. D to the negative 9 goes to the denominator as d to the 9th, that's correct. Okay. Any questions? Alright, moving on. The last part of chapter 4, scientific notation. We're not going to spend a ton of time on it. Have you done scientific notation before?
Yes.
Yeah? Do you remember it?
What is that at?
It's 4.7. Can I erase?
Yes. Yes. Oh, I don't like this. I remember.
Yeah, scientific notation's not a lot of fun. However, it is used. It gets me confused.
Is it with the zeros?
Yes, 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 yes. And it has to do with exponents. That's why we're covering it in this chapter. All right. Okay, so 4.7 is scientific notation. So standard form, we have the first example, A, as 41,800,000. So what we need to do is scientific notation is always a number, a decimal, and up to 1 or 2 numbers after that. So 41 million is where we're going to have the decimal. So we're going to move it right here. So 1, 2, 3, 4, 5, 6, 7. Is that correct? Yep. Okay, so 4.1 times 10 to the 7th is how that would be written in scientific notation.
4.18.
4.18. Apologize. Thank you. Good catch.
Wouldn't 10.7 mean 10 times 10 times 10?
Yes, it is. And that's why there's so many zeros. So we have
Okay.
we have where the decimal is, 1, 2, 3, 4, 5, 6, 7 places after where the decimal is. And that's why we have 7 as the exponent.
How do you know how many places to count?
You always go after the first number. So if it was 56,300,000, the first number is 5. That's where we're going to put that decimal, right after that first number. So how many back do we have? 7 again. So 5.63 times 10 to the 7. It goes after the first number, always after the first number. Okay? So I want you to try number 42. It's going to be a negative exponent. It's going to be 10 to the negative 7th. Write it down on your piece of paper. Yeah. Any luck? You stuck? A little bit? Okay. Alright, let me show you what we're looking at here. Okay, so for 42, we have 0.000000745. It's gone backwards. Instead of having all the zeros this way and counting this direction, we're counting in this direction. So 1, 2, 3, 4, 5, 6, 7. But it's a negative. It's a negative because we went that way instead of this way. So we still have 7.45, but this time it's times 10 to the negative 7. Yes?
Didn't you say we're supposed to put it to the first number, not to the two first numbers?
It goes in between the 7 and the 4. The 7 is the very first number that is not a 0. Okay? So if we had 0.0631, what do you think this would be?
Negative 6.31 times 10.
6.31 times 10 to the
So you just leave it like that.
Negative 4. Oh.
negative 2. You're right with the 2. See, we moved the decimal 1, 2 places, and because we went to the right, it's a negative. So for scientific notation, make